Math 1, Unit 4 Benchmark Review. Alright, so you'll want to try to do as much of this as possible with our calculators. There's some of this you can do without our TI-inspired calculators, but having those will definitely help on some of this. So, first thing, finding the mean. Remember that when we talk about the mean, we are referring to the average as well. It goes by both names. So, we add up every number, and then we divide by how many there are. So if I add those all up, we get 308. Then we divide that by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 308 divided by 14, and then we want the decimal here. And we get 22. So our mean is 22. Okay, number 2, same idea. So we add those all up to get 315, and we divide by, looks like there's 14 of them again. So 315 divided by 14 gives us 22.5. Okay. Now for interquartile range, we need to find the quartiles. And remember, we go the lowest to the first quartile, to the median, to the third quartile, to the highest. So that's like the lowest quarter of data, then the next quarter of the data, the next quarter, and the highest quarter. So 1, 2, 3, 4. So we line them up from smallest to biggest, or biggest to smallest, doesn't really matter, but smallest to biggest is usually the best. Then we find the median. So to do that, we go in between. So 3, we find the middle number. 3 more, 3 more, 2, 2. So our median would be 19. Okay? But we use that now to find our first quartile. Our first quartile is the median, the middle number of those numbers. So we find the middle. Now there's 2 of them, so we'd normally find the average of that, but they're both 16, so our first quartile is 16. And we do it for the other. We get 21 and 22, so we'd go the average of that, which would be 21.5. Then for the interquartile range, we simply go 21.5 minus 16 to get 5.5 for our interquartile range. That's the answer we were looking for. Okay. Now we do it for the other one. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. 6, 7, 8, 8. There's our median, 27. First quartile, 1, 2, 3. 1, 2, 3. In between 21 and 23 is 22, so first quartile is 22. In between 32 and 32 is 32. So subtract that. 32 minus 22 gives us an interquartile range of 10. Okay? Now there's a few different ways that we can find outliers. Okay? The first way is by hand. So we find the interquartile range. Okay? So I would find our median first. So in between 73 and 75, our median would be 74. So our first quartile would be 72. Our third quartile would be 77. So an interquartile range would be 5. Okay? So then I take my first quartile and I subtract 5 from that. So 72 minus 5 would give me 67. Okay? That's my low. Anything lower than that is going to be an outlier. Okay? Oh, hold on. I have to multiply it by 1.5. So I have to go 5 times 1.5. That's multiply by. So I go 5 times 1.5 to get 7.5. So then I go 72 minus 7.5, 77 plus 7.5. So our high would be 84.5, and our low would be 64.5. So if anything is lower than 64.5, it's an outlier. In this case, we have 2. Okay, anything higher than 84.5 would be an outlier. We don't have any, so our outliers would be 62 and 63. So that's one way to do it. The other way to do it would be to add it into your calculator using the lesson spreadsheet. So I'd start a new document. I would put in my lesson spreadsheet like we've been doing in class, and we would just do this one variable. So I'd type them all in, 62, 63, 72, 72, 73, and so on. Then I would go and add data and statistics and choose my stuff. So let's take a look at some of these screenshots here. So we'd start lesson spreadsheet, label it, type in all your data from that question, okay? Then we see our dot plot right here, okay? Notice those two are really far away from the rest of everything. So that kind of keys us into the fact that there's some issues here, okay? But we can see it better if we go to menu, plot type, and do a box plot. Because a box plot, if you have dots on here, those are your outliers. So that's another way that you can do it. So either way works to do it, okay? I'll just do number 6 by hand though, again. So once again, we find them, start out with the median. So it's in between 79 and 79, so it'd be 79 for our median. Then we need our third and our first quartile. So our third is 79 as well. And then 74 for our first. So then I find the interquartile range. So 79 minus 74 would give us 5. Times that by 1.5. We get 7.5. So then I go 74 minus 7.5 and 79 plus 7.5. And we get 66.5 on the lowest and 86.5 on the highest. So then we look, is there anything lower than 66.5? No. Is there anything higher than 86.5? There are, 93 and 94. So those are our outliers. Okay? Now, number 7 and 8 just want us to look at our scatter plot, see which one would be a good fit for data. First thing to notice, is this going to be linear or exponential? Well, if I look at this, looks like it's going up more in an exponential. So A is linear, so I eliminate that. C is also linear, so is D. So my only logical choice is going to be that exponential one, y equals 2 to the x. Okay, number 8, it looks like a linear equation, okay? Now, my slope, it's going up, so it's a positive, looks like a pretty strong correlation, right? So my slope is going to be positive, so I know that those negative slopes of negative 1.7 wouldn't work. My y-intercept would be somewhere around positive 3, so I know A wouldn't work, so it's going to be C, 1.7x plus 3. Okay, now you could put those scatter plots into your calculator and figure out which one would be the best as well, okay? Alright, number 9, which linear function is a good fit for this one? So we've got a negative correlation here, okay? Our line of best fit would be something around there, right? So we're going to have about a positive 20 for our y-intercept, so that gets rid of B and C, and a negative slope because it's going down, so that gets rid of A. We're left with D. Okay. So now number 10 says a linear function is used to estimate a data set. The residuals, remember that residual tests our line of best fit, is below. Okay. What does that tell us? So remember, what we're looking for is a random pattern. If it's a random pattern, then our line of best fit is a good line. If it's a shape, it's not a good line. So we've got a random pattern here, which tells us that we have a good line of best fit. Could it be the best? Maybe not, but it works. Whereas look at 11, same idea, residual plot. See how this one forms that shape right here? Okay, that's not a random pattern, so definitely this line of best fit is not good. Need something other than a line other than linear. So maybe exponential, maybe quadratic, maybe something else. Whereas this one, the line of best fit, if it's linear, works good. Okay? So there's those guys. All right, let's take a look at here now. So this is the same idea as our scatter plots. The difference is they gave us a table instead of a scatter plot. So could I type it into my calculator and get a scatter plot? Yeah, I could, like this. So I went and entered in all the data, okay, just as X and Y. Then we go to the next tab. Okay, we choose the X here and the Y here. We see the scatter plot, okay. So we could just stop right there and say, okay, so it's going up here, so it's going to be a positive 85, so it's either C or D, and then it's negative going down, so my slope negative 2.8, it's got to be C, okay. Or I could do this. I could hit Menu, and then I'd go down to Analyze, then to Regression, and then put Show Linear. And then I could try to match it up. So this is negative 2.8 plus 80, so a negative 2.8 or 2.0, so it's different than their line, but it helps me see what should be negative and what should be positive. So the answer is C. Okay, so I can try the same thing with 13, or I can try it by hand. So notice we start here at 15, so it's positive 15, so chances are it's going to be a positive 9, so either A or C. Then these numbers are getting bigger, which tells me the slope is positive, so it's going to have to be C again. All right, now looking at 14, it just wants to take this dot plot and tell us which data set is represented. So remember, each dot tells us the number, how many. So I have 1, 6. So I look, 1, 6, 1, 8, and 1, 9. So 1, 8, 1, 9, 2 11s, 2 11s, so I know it's not A, 3 12s, 1, 2, 3, so I know it's not B, 3 13s, 1, 2, 3, so I know it's not C, 2 14s, 2 14s, 1 15, and 1 16, so the answer is D. Okay, now 15 wants us to show the box plot. Here we can use the calculator again. We just type in the data in the list and spreadsheet, and then go choose that variable, and it makes a box plot, okay? And I'll show you how to do that as well. So from the calculator, remember, we open up the lists and spreadsheets, okay? Then you enter in your data, okay? Then we open up data and statistics, go down here and choose your variable. Then you go to menu, plot type, and you choose box plot, and this is what you get. Now this is a box plot we get, okay, but it could also be kind of tough to make sure it's matched up right. So what we'll want to do is match up the numbers. Now if you take your cursor and hover over each one of these pieces, it'll give you the exact number. So this one, 8, so our lowest number is 8, which they all match up for 8, okay? So we take a look at our next one. So then we hover over, this median is 10, so that first quartile is 10. This one's slightly off, we know it's not A. Okay, this one is slightly lower than 10, we know it's not C. This one is lower than 10, we know it's not D. So then we double check. So it looks like the median is slightly above, so we check our median. Okay, our median is this line right here, 12.5. That looks pretty close to 12.5. And we check our third quartile of 16, 16 for the third quartile. And then finally, our highest, which is 18 and 18, so we know for sure that B is our answer. Okay. Now we can also do this by hand, so let me show you how we do it by hand. We need those 3 points: the lowest, the first quartile, the median, the third quartile, and the highest number. So lowest is 2, highest is 20. Okay, highest of 20, highest of 20, lowest of 2, 20, 20, 2, and 2. So that didn't help us. Now we do our median. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 6, 7, 8, 9. So in between 6 and 10. So 6 plus 10 is 16, divided by 2 is 8, median of 8. Okay, median is this guy. So is that an 8? Yes. D isn't at 8. No, it's not D. B isn't at 8. No, it's not B. A isn't at 8. No, it's not A. So now let's double check with our other median. So 1, 2, 3. Our first quartile, I should say. First quartile is 4. Okay, does that match up? Yep, there's our first oh, right here. There's our first quartile. Okay. Then we do our third quartile. It's 12. And that matches up. So remember, lowest and highest become the whiskers. Median, first, and third make up the box. And that's how we get our box and whisker. So definitely is C. Alright, trucking right along. Now we can do a histogram. So there's two ways that we can do a histogram. Okay, we've got two histograms. We could do one by hand, one by calculators. Let's do the first one by hand. The thing with histograms is we need to make like a frequency chart. So notice here they did from 0 to 10, 10 to 20. Okay, all like that. So 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70, 70 to 80, 80 to 90, and 90 to 100. Okay, so looking at our numbers, do we have any 0 to 10? Our lowest looks to be 21, so 0 here, between 20 and 30, we would have 1. Notice we have our frequency on the left side. So here they're saying there was 1 from 0 to 10. We know that's not the answer. Okay, so let's see what else we've got. So any others in the 20? Oh, 24. So we have 2, right? Okay, then we don't have any in 30s. Then 40s, we have 1, 2, 2. 50 to 60, 1, 2, 60, 1, 70, 1, 80 to 90, 2, none into 90 to 100. Okay, so let's look at each one of these. So 20 to 30. 20 to 30 would be right here. They only have 1. No, it's not the answer. They only have 1 here. We know it's not the answer. They have 2 here. Okay, checks off. None into 30 to 40, or these two. 2 and 40 to 50, yes. 2 and 50 to 60, yes. 1 and 60 to 70, yes. 1 and 70 to 80, yes. 2 and 80 to 90, and none in the 100. Everything checks off. There's our answer B right there. Okay. We can also do this in the calculator as well. We do it the same way. We make a list and spreadsheet. We put our list in here. We go to the data and statistics. And instead of choosing a box plot when we hit menu, we actually choose a histogram. Okay. And it would look like this. So once again, I went to list and spreadsheet, typed all those into one column, then went to data and statistics, chose my name, which I called a histogram, so I put it there. Then it formed those like that. So notice frequency of 1, of 2, and of 3. So now we try to match it up. Now the difference is we might have done our spacing slightly different. Okay, so it looks like the way they did their spacing was about every 3. Now we can go down here and try to adjust our space. So, and this is a problem with using a calculator. Sometimes it doesn't match up exactly like theirs. So I've been trying to fix it, and if you click on Control, then Menu, no, not that one. I can get it so that it allows me to try to adjust it, but I'm having trouble getting it to work just right. Okay. Okay, I got it to change, but I had to go to a menu that popped up when I right-clicked, so on the calculator I'll have to figure that out and show you guys in class. But I could change the bin, and so now this should match up correctly. Don't pay attention to the numbers there so much. But we've got 1 for our first. Okay, definitely not B. Definitely not D. And then we've got 2. And this still might be slightly off, huh? And then it goes up to 6. Yeah, this is looking slightly off to me. I'm guessing it's probably C. So we'd actually have to do this by hand. Would be the best thing to do. So we make our frequency table, 56 to 59. There's 1. Okay, so definitely 1, so we know it's A or B right there. Then we'd go 60 to 63. So 61. 63, so 2. So right there, that tells us that it's actually A, isn't it? Now, I could figure out the rest, but I think we're pretty good, so I'm going to call that good. Okay, number 19. Nolan uses the equation y equals 6.5x to estimate the time it will take him to run between 1 and 3 miles, where x is the number of miles and y is the time in minutes. Which statement is true based on the equation? Alright, so we've got an equation there. So that 6.5 would be our slope. That's how it's changing, right? So it'd be he goes where x is a number of miles and time in minutes is y. Remember, slope is y over x, so it would be 6.5 minutes per every mile. So 1 mile. So it wouldn't be A, because that's 3.5 minutes. Okay. It's not C because the y value goes on top. Okay, and it's not D, so it's got to be B. And that's a lot of what these ones are doing. So, Coach Thomas records her athletes' performances at recent softball games. She uses the information to find an equation to represent the number of times a player should reach first base for any number of bats. Her equation, 0.32x plus 0.06, where x represents the number of times at bat and y represents the number of times reaching first base. So, the y-intercept would be 0.06 if you had 0 at-bats, right? Which doesn't make much sense. If you don't go up to bat, you can't make it to first base, but the way the formula works. So then this would be 0.32 over 1. So you'd have a 0.32 chance of reaching first base for every 1 at-bat. Okay? So 0.32, if we think of that as a percent, would be D. That for each at-bat, there's a 32%. Okay? 0.6% wouldn't move the decimal enough. 3.2 wouldn't move it enough. These are the y-intercepts, so that's why they're not included either. So that's why it's D. Okay, number 21 is very similar to number 19. So we've got y equals 10x. So remember, the 10 stood for minutes. So in 10 minutes, he can go 1 mile. Okay, so that would be D, right? Then Jordan has a loan at the bank and makes monthly payments. He pays different amounts each month, but he can approximate the total amount he owes the bank using this equation, where y is the total amount owed and x is the number of months in the loan repayment. So that negative 120 would be, that's how much less amount owed every 1 month, because it's y over x, right? Okay, the y-intercept would be at the first 0 months of repaying. How much did he have? 1,550. So, he started with a loan total of 120. No. Okay, he started with a loan total of 1,430. No. He started with 1,550. He pays approximately 120 each month. Yeah, it goes down, so that's what the answer would be. He's not paying the 1,550, that's what he owes. Okay. Now, questions 23 to 26, we're using these three. That we're looking at the strong positive, or weak negative, weak positive, strong negative, which I don't see that one there, or no correlation. So a negative 0.024, that's really close to 0. That would be a no correlation. Okay, 24, correlation coefficient of 0.945. So it's positive, and it's very close to 1, so it would be what we call a strong positive. Okay, so it would be A. 25, we have a correlational coefficient of negative 0.89, which is close to negative 1, so that's a strong negative. Apparently I needed to put an E here. Strong negative. So that we'll call that E, strong negative. And 0.045 would be a weak positive, so that would be D. Okay. To have a weak negative would be like negative 0.045 or something like that. Okay. 27 says event X and Y have little or no linear correlation. What statement do you know? So there's no correlation, so if X increases, Y will increase. That's incorrect. If X increases, it is unknown how Y will change. If X increases, Y decreases. To have no correlation means one doesn't change the other one. And it's not responsible, so it's got to be B. No correlation means we don't know what's going to happen if one increases or decreases. Okay, now if we have a strong positive linear correlation, okay, is event X is responsible for change in Y? That's causation. We can't ever say causation based off these graphs. We will know, because it's strong positive, that if X increases, Y is going to increase. Because a strong positive would look something, like this. So as X gets bigger, Y gets bigger. If it was a strong negative, like this, then it would be C. But it's not, so it's got to be D. If X increases, Y increases because of that. Okay, a weak positive, okay, what do we know? Is it responsible? No, definitely not. Will we not know how it changes? Not really, because even if it's weak, okay, there's still going to be a connection. So if X increases because it's positive, Y would be likely to increase. Okay, there's a chance it will. It may not quite like we think, but there's a chance. Okay, 30. A weak negative. Now negative, remember, is when it's going down, so as X gets bigger, Y is going to get smaller. So as X increases, Y is likely to decrease, B. And if they have a strong negative, then we know for sure that if X increases, Y is going to decrease, C. All right. Just about done here. Just got a few more, okay? So, 32. Two groups of students, Group A and Group B, have the age distributions shown below. Which statement about the distributions is true? Distribution B has a larger mean, but the medians of both distributions are the same. So, does it look skewed at all? Looks like the majority of our data is here, okay, whereas with distribution A, it's more spread out. So what that tells me is most likely our mean for B is probably going to be higher, our median, okay, but our mean could be close to the same. So B has both a larger mean and a larger median. That's a possibility, okay. No, it's not this one. B has a smaller mean. I don't think B is going to have a smaller because the majority of data is here, so that's going to pull the median up. Distribution B has a smaller mean and a smaller median. Definitely not, so I think we've got to go with B on that one. Okay, now let's look at 33. Okay, data set 1, data set 2. So we're looking, which one do we think has the greater mean? Which one has the greater variation? Well, I'd say data set 1 has greater variation. Okay, so I don't think it's C or D. Looking at this, I would say probably data set 2 has the greater mean. So I would go with B. Okay, now we're down to a minute, so let's talk about these last ones. So we're seeing how... So we're looking at 34, and the 19-year-old turns to 20, so that becomes 20. So if we think about that, that's changing that one number higher. That's not going to affect the median. The median will stay the same, but the mean will go up a little bit bigger. Okay? Now, 35, same idea. If this person leaves, well, that's going to affect the median and the mean, right? The mean is going to be higher, and the median will possibly could be higher. Okay? So, there we go, guys. That's it.